The types of automotive air conditioning compressors are 1. Automotive compressor with fixed stroke piston with clutch coupled to the vehicle's engine. 2. Automotive variable stroke piston compressor with clutch coupled to the vehicle engine with mechanical capacity control valve. 3. Automotive variable stroke piston compressor coupled to the vehicle engine without clutch with electronic capacity control valve. 4. Automotive vane compressor with clutch coupled to the vehicle's engine. 5. Automotive scroll compressor with clutch coupled to the vehicle's engine. 6. Automotive scroll compressor hybrid. 7. Automotive electric scroll compressor. 1. Automotive fixed stroke piston compressor with clutch coupled to the engine of vehicle A. It is a multi-piston compressor driven by a fixed stroke plate used mostly in medium to high power vehicle engines. B. The compressor does not have any system to adapt to the required thermal load in the car. C. The system turns the compressor off and on. Disconnect and connect the clutch to suit the load of the car. 2. Automotive variable stroke piston compressor with clutch coupled to the vehicle engine with mechanical capacity control valve. It is a multi-piston compressor driven by a variable stroke plate used mostly in medium to low power vehicle engines. B. The compressor adapts to the required thermal load on the car, regulating the length of the piston stroke, avoiding continually turning the clutch on and off. 3. Automotive variable stroke piston compressor coupled to the vehicle engine without clutch with electronic capacity control valve. Tau. This type of piston compressor has an electronic or solenoid valve whose function is to allow or not the passage of refrigerant to the compressor. B. The management of the control valve is carried out by the electronic control of the air conditioning, taking into account the reading of pressure and temperature sensors. C. In addition, the electronic valve is in charge of controlling the length of the piston stroke to regulate the cooling capacity. D. This compressor does not need a clutch, since the compressor does not work when the control valve does not allow the refrigerant gas to enter the compressor. 4. Automotive vane compressor with clutch coupled to the vehicle's engine.
In the figure we can see how the volume of gas in the vane compressor is progressively reduced.
Regarding the use of these compressors, their use in automotive air conditioning stands out, where due to their high efficiency and low noise, they are very attractive, especially in smaller car models. However, for many automotive technicians, vane compressors are a long way from matching the durability of the reciprocating compressor often used in this industry. 5. Automotive scroll compressor with clutch coupled to the vehicle engine.
In the figure we can see how the volume of gas in the scroll compressor is progressively reduced. It has an orbital displacement. Compression is done by volume reduction. The compressor assembly is made up of 2 spiral-shaped rotors. One of them is fixed in the casing and the other is mobile, driven by the motor. They are mounted 180 degrees out of phase.
Automotive scroll compressor hybrid.
Tau.
Hybrid vehicles are powered by both the gasoline engine and the electric motor. B. Since the combustion engine is not always running, an alternative method must be used to compress the refrigerant in the air conditioning system. C. The hybrid compressor essentially consists of 2 small scroll-type compressors linked together.
D.
The operating principle of each scroll compressor is the same as explained above.
End.
The front half is a traditional mechanical compressor driven through the vehicle's engine via the accessory belt. The rear half of the hybrid compressor is powered by a 144-volt AC 3-phase electric motor. G. The electric motor is ultimately controlled by the on-HVAC system, which determines the cooling demand and sends a signal to the air conditioning compressor controller. The controller takes 144 volts DC from the hybrid battery pack and converts it to 144 volts AC to produce the required compressor speed and provide proper refrigerant pressure. Automotive electric crawl compressor A. They use an electric motor independent of the vehicle's engine to drive the compressor.
P.
The motor is brushless, which uses a permanent magnet as a rotor and a coil for the stator.
C.
It requires an inverter to drive the motor.
D.
The inverter converts the direct current from the battery into alternating current for the motor.
N.
The air conditioner controller sends compressor rotation speed signals to the inverter to control the rotation speed of the electric compressor.
F.
As compressor oil can reduce the cooling performance, therefore separator is mostly used to separate the oil from the refrigeration cycle and improve the cooling capacity of the air conditioner.
G.
The electric motor works with a high voltage of 200 or more. To insulate the electric motor and the compressor casing, compressor oil with high insulating properties is used.
N.
The trend for many years is to integrate an inverter with a compressor in a single component.
J.
The controlled speed of revolution contributes to energy savings.
K.
The economy factor is essential, as the less energy you use to drive the compressor, the more you can use to drive the hybrid or electric vehicle. Thus, the vehicle's range will increase when the compressor offers high performance at low revs.
N.
The compressor's internal electric motor allows the air conditioner to continue to run, even when the hybrid or electric motor is idling off. The electric compressor works independently of the motor.
No.
Electric compressors are quieter. This provides a comfortable environment without passengers having to listen to unnecessary noise. The type of oil used in an electric automotive compressor generally differs from the oil used in mechanically driven compressors. The highly insulating oils are recommended to protect the electric motor. If you use the wrong oil, it may cause a short circuit and destroy the electric motor of the compressor.
N.
If you use a V-tint, be sure to use the correct SAE-approved type of tint.
S.
Any other cheap V-dye can create problems with the insulating part of the compressor oil.
N.
Like self-powered electric compressors, they are hermetically sealed, there is no shaft seal, and no potential risk of refrigerant leaking into the outside air.